Hello everyone and welcome to today's webinar, MEP Project Documentation in Revit, 9 Easy Steps. First of all, this webinar is a part 3 of our webinar series for project documentation, and it's designed for MEP engineers, but if you are from a different discipline, you will see useful examples as well. As for myself, my name is Dovydas Stanaitis, and I'm a BIM application engineer here at aga-cad. Before joining here, I worked as an MEP engineer for 5 years. I've been designing mechanical, plumbing, and gas supply systems for administrative, residential buildings, and sports arenas for projects in Lithuania and Norway. In aga-cad, I'm responsible for our MEP tools, also Smart Documentation and Smart Browser. If you have any questions about any of these tools, feel free to reach me by email. As a company, aga-cad creates applications for Autodesk Revit based on the needs of the world's leading BIM practitioners. Our goal is to help Revit users eliminate tasks that do not create value and let them focus on what is actually important. We are authorized Autodesk developers, and our first Revit add-on was created in 2008. Today we have a wide range of BIM solutions for Revit. We automate various modeling, data management, and documentation tasks, and our tools can be used by engineers of many different disciplines and can be customized for different needs or technologies. In this presentation, I will talk about our latest product, Smart Documentation. It enables all Revit users, including MEP engineers, to get accurate project documentation quickly and easily, replacing hours of drafting with just a few clicks. To this day, many MEP engineers manually place dimensions and tags, enter data, and create sheets for repetitive levels. So in the next 30 minutes, I will cover ways to save time in documenting drawings by automating these steps. And I will show you other features that can improve overall quality of your Revit model and its documentation. So let's jump into the live demo. I have my Smart Documentation toolbar here, and I will drag it onto the drawing area so that I always have it available. Now, I must mention that it's a rule-based software, but I will try to show configurations window as little as possible today, as not to make this presentation too technical. And we have both the imperial and metric versions of this software. I would like to start with my ventilation plan. Here I have some air terminals placed in for my ventilation system. So for installation, these air terminals usually need to be dimensioned to the closest wall. To place these dimensions, I will use predefined dimensions. It has a functionality called toNearestElement. Let me run it. So this will take a couple of seconds. While it runs, let me tell you that predefined dimensions can be used on any loadable families and most of the system families as well. And as you will see, we can dimension to linked architectural or structural models too. And now it's finished, and every air terminal has received 2 dimensions, one horizontal and one vertical. And I have specified to dimension center reference planes of a family, but it's possible to use other reference planes or even edges of the geometry. As for air terminals that are flush with a wall, like these air supply grills, you can see that only one dimension was placed because other one would have been a 0 value. Predefined dimensions can also place dimensions between elements, not only to the closest structure. In this view, I have placed openings for my MEP services. Now I can dimension all these openings in a view at once, but that would overwhelm my drawing. So I will select a run of openings and dimension selected elements. I have another configuration ready. And now this has dimensioned sizes of my openings and also distances between one another. And on the right side, where the distances are small, dimensions have been automatically moved out. If more reference points are needed, grids can also be included. So I will repeat the same configuration, but with grids also selected this time. So dimension selected elements. And now these openings are also dimensioned, and I have distances to my grids too. Smart documentation has one more way of inserting dimensions. It's called quick dimensions, and it can create dimension chains between two selected points. To demonstrate it, I will go into a roof plan, and in the settings here, I have specified categories of elements that I want dimensioned, so my MEP elements, and I have also selected grids. And I have specified to use outer faces of ducts instead of center lines. To start, I will hit Insert Dimensions, select a point on a plan, and to finish a dimension chain, I need to select an element. And just like that, everything in between has been dimensioned. To finish the whole drawing, I will repeat this a couple more times. So a point and an element, a point and an element. I will do a couple more in this direction. I think I needed one here. And just some finishing touches on this side. And just like that, I have the whole drawing dimensioned. But if I decide that I want to join some of the dimensions, I can do that as well. So join dimensions, select one, then another and another, and when I click escape, all the dimensions are joined together. For my next example, I will go back to my ventilation plan 1 drawing. Smart documentation also has the batch element tagging functionality, and we can compare it to Revit's own tag all not tagged. Let's say that I want to tag ducts in this plan. With plain Revit, I would need to either manually select all the elements that I want tagged or tag every element in view. And let's do that. So ducts. Now if I do that, my drawing gets buried in tags because Revit tags every smallest piece of a duct. Let's go back. With smart documentation, we can set up rules for tagging. In here, I have set up a filter for length. So length must be greater than 400 millimeters. And I will run this configuration. So now only the relevant ducts in my view are tagged. And my drawing isn't overwhelmed by the number of tags. And one more feature of smart tags is visible in this view. It's called Avoid Tag Overlap. In here, this tag has been moved down to avoid a collision with another tag. Now going back to the roof plan, and I can show you that it's possible not only to filter by a parameter, but to use multiple different tag families for the same category of elements. I will be using different tags depending on if a duct is insulated or not. Because using a tag with insulation thickness onto an uninsulated duct gives me a result like this. The insulation thickness label is still visible and showing +0, and I don't want to see that. And I will be using yet another tag with elevation for rectangular ducts only. So in total, I have a configuration with 4 possible tags. Let me show you. So in here, every tab represents a different tagging rule. And I'm also discarding ducts that are shorter than half a meter. So let's run. And all the ducts are tagged. So round insulated ducts have 1 tag. Rectangular insulated ones have another one with elevation. And rectangular uninsulated ones have yet another one without insulation thickness label. Okay, now next group of commands is called views. It can create views for selected elements and combine that with element tagging and dimensioning rules. So newly created views can come already tagged and dimensioned. I have an example in level 1 heating drawing. For MEP engineers, this functionality can be useful in generating piping spools. I will select a piping run and a couple more elements here, and create multi-element views. I will give this a name and select an element for a front view reference. So currently views are being generated for this selection, and also they're being dimensioned and tagged. Give this a couple of more moments. And finished. As you can see in the configuration, I have selected to create a 3D view, a left and a front elevation, and a view from the top. And I have assigned a view template and a piping spool dimensioning rule and a tagging configuration. So let's look at the result. So I have a 3D view and a tagged and dimensioned front view, left view, and a plan view. And these views can then be placed onto sheets, but I will cover sheets in greater detail later in this presentation. For now, I can show you a sheet of another piping spool, and this was generated automatically using one of the sheet's commands. Okay, on to the next thing, which is element numbering. Let's say that I want to number all the heating equipment in my project, but I want to follow the room numbering order. I will go into the rooms plan. And here you can see rooms that are in the linked model. And the numbering starts in the hallway, and then it continues right to the stairwell and goes clockwise. So 1, 2, 3, 4. And inside apartments, I have another subnumbering where the living room is first, then bedrooms follow, and then the restroom. And it's the same for all the apartments. To make this more interesting, let's say that I want to number by room number, but I also want to start over at every level. With element numbering, I can create numbering rules using parameters from a family, its host, or a room, or a space. So element numbering. My equipment is heating equipment. I have a configuration. So first, I will be restarting at every level. I'm filtering only the heating equipment. And I'm sorting by room number. And in the final tab, I specify that I will use a mark parameter. And I'm writing a number from the level name alongside with my calculated value and some prefixes and suffixes. Okay, and all the elements are numbered. Let's take a closer look here. So L1 refers to a level, and the numbering goes 1, 2, 3, then 4, and it continues inside apartments. So in the living room 5, 6, then bedrooms 7, 8, and restroom 9. And just like that for the rest of the level. And it finishes here, 27, 28, 29. And if I go into another view, let's look here. You can see that the numbering restarts from the living room again, 1, 2, then bedrooms. But I have a prefix with a level number, L4, so I know that every element has a unique number. Okay, for another numbering example, let me go to the underground wastewater plan. And here I have my risers already tagged, and I have highlighted them in red color. To number all these risers, I will use a configuration for pipes. So first I'm filtering by bottom elevation, which must be less than 0, then top elevation, which must be greater than 0, and system name must contain WW, so only the wastewater system. And I'm sorting by X and Y positions, meaning that the numbering will start from the left side and go to the right. But if I have multiple elements at the same X position, I will sort by Y value next. In the final tab, I specify that I will use a mark parameter, and I'm writing a calculated value with a riser prefix. Okay, and all the risers are numbered, and the numbers go from left to right. Now in these drawings, coordinates are also sometimes needed. Coordinates in Revit are basically a parameter that every element has, but it's invisible through the Revit interface. With autofill coordinates, I can write these coordinates onto a text parameter, so it can be visible in views and schedules. So pipes, selecting a parameter, and we can use both the project base point and the survey point. And all of my risers are now with coordinates. And the default format is X and Y values divided by a semicolon. If you would like a different format, we can create that using element numbering. So another configuration, I will go to the last tab and drop the X and Y parameters to the right side, and I will come up with my custom prefixes and suffixes. So X equals, Y equals, and a semicolon here. Okay. And now all the risers are in the custom coordinates format. So not only did I save time by not having to do spot coordinate for every element, but I have this information in a parameter, so it's visible in schedules as well. Let me show you. And then I can use that to transfer data to some other outside software if needed. Okay. Now for the last numbering example, I will go back to my ventilation plans. And in here I have my VAV valves and fire dampers already tagged. And let's say that I want to number them, but I want to number them in my specific order by picking them one by one. I can do that using element mark one by one. First, I will select an element to detect the category. I will reset the counter. And I'm using a configuration which groups elements by their family name, meaning that I will have separate numbering chains for every family. And I'm also writing the type mark value as a prefix. So you can see as I hit on elements, they get consecutive numbers. But if I switch to another family, my numbering restarts from 1 again. Now, if I go back to VAVs, you can see that I pick up from where I left. So 5, 6, 7, 8, and it's the same for fire dampers. Okay, I can even close, I can even escape and go to another view and continue from there. So VAVs and fire dampers. And when I'm finished, I will click escape and close. Okay, so next group of commands is called images. Rebar images aren't really relevant for the MEP Engineer, but QR codes can be quite useful. Good example is these VAV valves. Often they are pre-programmed in a factory, and then in a building site, they must go exactly where planned. But when tens of these get to the building site at once, it can be a hassle figuring out where which should go. And to help with that, a unique QR code can be generated, and later it can be scanned by any smartphone to tell you its specifications and where the valve is supposed to go. So let's do that. And to save you some time, I have already written a room data into a comments parameter for every valve. I was using element numbering for this. So every VAV has a room number inside its comments. So QR codes. My category is duct accessories. I have a configuration. First, I'm filtering only the VAVs, and I'm using an image parameter. And I will generate an image which, when scanned, will read the mark value, system abbreviation, so S for supply VAVs, R for return VAVs, then comments, which, as we already know, is a room data, and an airflow. Okay? And images have been generated. To view those images, I need to go onto a sheet and drop the schedule here. And the QR codes are now visible. You can point your smartphone to any of these to check if they work. But I will use an online QR reader. I will use a screen capture. Copy to clipboard. Scan. And as you can see, it says VAV11, S for supply, then room number, and an airflow. Okay, next in line is legends and data. So sometimes in a project, you might need data that isn't in your Revit file. Oftentimes it's an Excel spreadsheet. With import data from Excel, I can select a spreadsheet. I can import just a single sheet or a multiple sheets. We'll choose this one, and I can import it as a drafting view or a legend. I will choose a legend. And we can import cell fill colors as well. So draw a table, and I have it in my Revit file. I will now open the spreadsheet and make some changes to it. So I will change the column width and maybe remove the cell fill colors. Save and close. Now when I click Manage Tables, I will see a yellow exclamation mark next to my spreadsheet name indicating that some changes were made. I will update selected. And I have the latest version of my document. I will now go into the ventilation plan 1 and drop this onto a sheet. And I will get back to this one later. Now for a final part of a live demo, I will show you how to create smart legend views and place them onto sheets in 2 different ways. So in this project, I have some supports modeled for my MEP elements, as you can see in this view. And let's say that I need to make a specification of these supports for my prefabrication team. I will go into an empty legend view and start creating a table here. So I will draw a rectangle and place a legend component of one of these supports. I will use a front elevation. Front elevation, and I will nudge it up a bit. Next, I will create a row for text. Now for smart legend creation, I need some special annotations families. They can be loaded with this button. And I will drop it onto the right side here. And on the left side, I will place a simple text field. So next, I will select everything in view and create edit legend. So smart legend creation works by selecting parameters that you want to see in a table. And here I have already selected some relevant parameters for hangers and supports. And I have my count value, which will calculate totals. And I'm grouping by model parameter first, then family name, type name, and so on. So I will select only the complete hangers and finish with the table. First, I need to select a line for a row height and elements to be added down. And as you can see, my text field was replaced with parameter names. And finish, I will select a line for a column width and elements that will be arrowed to the right side. Give this a couple of moments. So the table is currently being generated. Okay. And I have a table of all the supports and hangers in this project. I have specifications for every size and how many times it was used in a project. Now, if I made some changes to my hanger layout, I can easily update this table using update all legends. But I will do something slightly different. Say I want to place this table onto a sheet. To do that, I will need to break it up first. So create edit legend. Delete rows. And I will set up a split at every family used. And then redo the table. So now I will have separate tables for every family of a hanger or a support used in my project. Okay. And now I have smaller tables in separate legend views. So now I can place them onto sheets. To do that, I will use distribute views on sheets. Let me go into the configuration. Here I have filtered only the legends. So I will select legends that I want to place onto sheets. And currently, you can see that I have only 3 sheets in my project. I will hit place views on sheets. And I have 3 more sheets created. Let's take a look. And all my views selected views are spread across these 3 sheets. And I have used the same command to generate my piping spool drawing. Now, legends can also be created for a more conventional use. Let's create an air terminal legend for my ventilation drawings. So, air terminal legend, and I have a base already prepared. I will select everything in view and create edit legend. And this time I will create a table as a legend as a vertical table. So I need some different parameters now. I need only the family, model, and type comments. Okay. I will hide the first. I will leave only the model parameter because it has the names of my air terminals. And I will group by type comments first, then family, then model. And let's create a table. So I will need to do the first step even though I only have one parameter visible. Okay, and I have a table, and here I can see legend components for every air terminal and a name next to it. I will go into my ventilation plan 1 and drop it onto a sheet. And I would say that my plan 1 drawing is finished, but now I need to generate sheets for the remaining levels. To do that, I will use Manage Sheets. I will select one sheet as a template and create new sheets. Next step is to select views that I want to place onto these sheets. So I want the rest of my ventilation plans. And very importantly, I have this checked, which will place views exactly as in my template sheet. Next step is mapping. Here every row represents a newly created sheet. I will group views by type, and my plan views are sorted. And I also want to keep the legends. So I will select a legend for every sheet. Okay. And the last step is naming of new sheets. So this is plan 2, plan 3, 4, 5, and roof. Okay. So currently new sheets are being generated and viewports placed on these sheets. Okay. And okay. And I have 5 more sheets created. So now I have all the remaining levels, and my viewports and my legends are in exactly the same position as in my template sheet. And I have the roof plan as well. So I think that was all that I wanted to show you today. Now we can go back to the slides for some final finishing words. So, some takeaways from today's webinar. Smart documentation can cut the time required to properly document the Revit model by automating the fundamental annotation features of Revit: dimensions, tags, legends, views, and sheets. And with this software, I can document my MEP project of this size in 15 minutes, which would take me about a couple of hours in plain Revit. Smart documentation also provides additional value for features that aren't in the out-of-the-box Revit, like element marking and data extraction, and also QR code generation or Excel spreadsheet import. Also in this webinar, I have tailored my examples for the MEP engineers, but our software can be just as easily be used by architects or engineers of other disciplines. To try it out by yourselves, go to aga-cad.com and get a 14-day free trial for smart documentation. Or you can contact us at info@aga-cad.com for a quote or to schedule a live demonstration. And also make sure to check out other products for Revit for MEP design. And for any questions, feel free to reach me at dovidas@aga-cad.com or at helpdesk@aga-cad.com. Thank you all for watching, and I will see you in future webinars. Have a good day.
aga-cad, building BIM together.